All right. So, hello everyone. So, we are live right now. Okay. So, I hope I'm audible to all of you and my video is visible. So, please give me a thumbs up if we can start with the class today. So, again, welcome to this particular channel of Pradhan Academy. So, today we have another session where we are going to discuss about 3D geometry, right? So if you are someone who is new to this particular channel and you are watching these sessions starting from this particular video, then consider subscribing to the particular channel, right? Because we are coming up live daily and we are discussing about different topics on maths so that I can help you out with all of your CBSE board examinations. So as a very experienced person from this particular part of maths, right? So I can help you out, and if you just take my advice, so I have already secured 100 upon 100 in my CBSE board examinations, right? So I will be helping you and guiding you through the different portions of your maths part so that you can also do the same and you can also get the full marks in your maths paper, right? So you all know that the maths subjective paper is basically consisting of 80 marks, right? And the remaining 20 marks is from your projects or assignment that you basically make from in your school, right? So we are basically focusing on the 80 marks part, that is basically your theory paper that is going to be happening on 8th of March, right? So I hope that you have already started your preparation and you have almost at the end of the revision of the syllabus, right? So these sessions are basically going to help you out for the entire part of your class 12 syllabus, and I'm also going to discuss about how you are going to solve different types of questions, and we are also going to see that how do we use that particular concept to solve different previous year problems, right? So today we are again back with the topic of 3D geometry. So if you have watched the previous lecture of 3D geometry, in that particular lecture I have covered the straight line part, right? So if you have watched that particular lecture, so you must know that I have covered straight lines. So straight lines is done. So today we are basically mostly focusing on planes. Okay. So the planes part of the 3D geometry was left, right? So I hope you will be starting to understand this part, right? Now this part is not that difficult. It's also very similar to that of a straight lines, right? So again we are going to use the vectors. We are going to use notations of cross product, dot product, right? And we are going to use that to different conceptual questions, right? So stay tuned for this particular video, and if you are starting to watch this particular video from this particular moment, please first of all I would all request you to please like the video and share it to all your friends. Okay, please share this particular session to all your friends so that they also know that we are live, and please ask your friends to come and sit with us so that we are also going to crack this particular examination of CBSE 2025 paper, right? So let's start. So I will be the instructor for this particular session. Let's get started. So today our goal is basically to discuss the 3D geometry, especially the part of planes. So as of the last lecture of 3D geometry, we have covered the straight lines in 3D, right? So we are basically left to cover the planes part. So we will be discussing the planes, we'll completing the planes part right now. We'll also see how we basically have to understand the concept of vectors and its use in the concepts of 3D planes, right? Then we will try to understand how we are basically using that particular idea of the general representation to solve different sets of problems, right? And we also discuss about some of the different techniques to solve the same type of problem but in a different ways. So if we are understanding a problem or trying to visualize a problem in 2-3 different methods, then only you will have conceptual clarity, and that will help you to proceed for different sets of problems. Okay, then we will also have some analysis on the exam pattern and the paper analysis, right? So stay tuned for this particular video. So if we are ready to go, please give me a thumbs up so that I can proceed with the session. Okay. Hi Niti Creation, good evening. So are your preparations going good, Niti? So I hope you are able to start with the video, right? So we can start with the session today. So before we start, we will have some quick recap of the initial part of the 3D geometry, especially the planes, right? So let us have some quick recap. So this is something that I will be discussing first of all before we start with the topic of planes. So what is basically plane, right? So if you look at the piece of paper, that is a plane, right? So in 3D, how do we define a plane? So it is basically said that if a line joining so if a line joining any 2 points on a surface lies entirely on it, or if a line joining any 2 points on the surface is perpendicular to some fixed straight line, then that particular surface is called as plane, right? So what is basically mean by that? If I have 2 points and I join the 2 point consisting of two line segment, then that particular line segment will entirely lies upon a particular surface, such that if a line joining any 2 points on the surface and are perpendicular to the same fixed straight line. So let us say we have perpendicular same fixed straight line that is fixed to the all the planes. So that is a perpendicular to which is common from all the planes. That particular surface is basically called as plane, right? So this is called a plane. So this is what we called as planes, right? And this is called as a normal vector. Okay, this is a normal vector of the plane, right? So for the plane, we basically have one particular fixed point, so and one particular vector which is perpendicular to the plane, right? That's how we define any general plane, right? So let us call this n cap or n vector as the perpendicular vector, and any point on the plane, let us call that particular point with the position vector a vector, right? Or we can also write that point as a comma b comma c, right? That is how we define a equation of plane. So in order to define an equation of plane, what do? We try to consider any general point, lying on the plane, right? So let us say I have a known point A, and that particular point has coordinates a comma b comma c, and any general point R that has a coordinate x comma y comma z, right? So I can just try to connect this particular vector, and I can write the RA vector, right? So I can simply write RA vector. So let us call this like R. Okay, so I can write the AR vector as. So in vector, we basically, if we have 2 points, we can simply write a vector by subtraction of the final point from the initial point. So that will basically become x minus a I cap plus y minus b j cap plus z minus c k cap, right? That is what is the definition of the AR vector, right? Now, in a plane, if we have perpendicular to the plane, let us call this vector, which is n vector, right? Which is also called as normal vector, right? Normal vector, right? Now, from your basic geometry or basic concept of your algebra of vectors, we have seen that for perpendicular vectors, the dot product is equal to 0. So therefore, you will have AR dot n vector is equal to 0, right? So if you just do this part, so you will get the what is called as the general equation of plane. So what is the general equation of plane? So general equation of plane, I'm writing it over here. General equation of plane in vector notation is basically given as R vector, which is the position vector of this point R, and A vector, which is the position vector of this point A. So R vector minus A vector dot n vector is equal to 0. So which will therefore give me the general equation of plane as R dot n is equal to A dot n, right? And A dot n is basically a constant number, that is I can call that as D, okay, some constant. So R dot n is basically equal to constant. That is the general vector form of equation of plane. Okay, so that is what I've written over here. So you can see the general form, the equation of planes can be written in first of all normal form. That is, the equation of plane is given by Lx plus My plus Nz is equal to some constant P. That is basically called the normal form of a plane, where L, M, and N are basically the direction cosines of the normal to the planes. Okay, so this is simple. So if you have the direction cosines of N, so this is basically just multiply it and you will get it, right? Similarly, the general form of plane is can be written as in terms of ax plus by plus c plus d is equal to 0. That is the general equation of plane, right? So any polynomial expression of first order of 3 variable is basically a equation of plane, right? Or a linear equation, I would say. Now, also the equation of plane passing to this particular point x1, y1, z1 is given as a times of x into x minus a x1 plus b times of y minus y1 plus c times of z minus z1 is equal to 0, where a, b, c are just nothing but they are the direction ratios of the normal to the plane. Similarly, we can also represent the equation of planes for 3 points. For example, if we have 3 points in the plane, let us say this first and 3 points. So what we do, we just try to connect these two vectors, and from these two vectors, let us call this a vector, this b vector. So from this two vector, we first of all find out what is a normal vector. So normal to the two vectors basically given as a cross b, right? That is basically the cross product. So this will give me the normal vector, and we have any initial point. So we have the 3 points. So out of the 3 point, any of the point we take, and we can do the notation that is r dot n is basically equal to that in any initial given point in dot n vector, right? So that is how we are going to get the equation of plane, and that is something that I have written in form of the determinant form over here. Okay, so if you just solve this in terms of the Cartesian coordinate notation, you will basically get this determinant form, which is basically equal to 0. Okay, is this clear? Now also, if a plane is having intercept a, b, c on the axes, then I can also write the equation of plane as x by a plus y by b plus z by c is equal to 1. In vector notation, I have already told you that it is basically r dot n cap is equal to a dot n cap. Right. Similarly, the equation of any plane which is parallel to the given plane ax plus by plus cz plus d is given as ax plus by plus cz plus lambda is equal to 0. So that particular only, so parallel planes only defined by the constant. Okay. So where lambda is basically any scalar. Okay. Now also with that, if I have to find out or write the equation of plane passing through the given point A and it is parallel to two vectors, then the general equation of plane. So we know that it is parallel to B and C vector. So B cross C will generate me the vector which is perpendicular to the plane, and A is any vector which is lying on the plane. So I can write the n vector as B cross C, and the definition of the equation of vector is r dot n. So r dot n vector is equal to a dot n vector. That's how we get the equation of the plane, where we have the two parallel vector to the plane and a position vector on the plane. So these are all the different notation on how you are basically going to approach the equation of planes in different notations. Okay, I hope this part is clear. Please let me know if this part is clear or not. Yeah, hi Naresh, how are you? Okay, Naresh, like you want my mentorship till April attempt. For that, how to contact you? Okay, I will send you a number. Wait a second. Okay, so you have to contact on that particular number. So if you just go to the description box of this particular video, you'll find out a contact number. Okay, you will find out a Telegram group as well as contact number. So you can check out that. Okay, Naresh. So please, you can contact that given corresponding number in the live chat. Fine. So you can definitely contact me through that particular thing. Okay. So if you are going for one-to-one mentorship regarding your JEE mains also and JEE advance also, I am there to help you out with this. Okay. So let's start with that. I hope you are able to understand this part of the explanations. Okay, Naresh. Shall I proceed? Okay. So this part of the equation of planes, which is very important for your CBSE board examination. I hope this part is clear, right? Let's now move to the next point, which is also very important regarding the concept of planes and a point. Okay. So whenever I have a point and a plane, some of the things are very important. That is, for example, if we have the equation of plane known to us and we have any given point which is not lying on the plane, let us call this point as P, something as x comma y comma z. Right now we will have multiple definitions, or we will have multiple operations consisting of a particular point and a plane. What is that? Now see, for example, the first point over here is, if you note it over here, is that a plane will divide the three-dimensional space into two equal segments. Okay, a plane will divide the three-dimensional segments into two equal segments. So a point A, which is given as x1 comma y1 comma z1, and point B, which is given as x2 comma y2 comma z2, will lie on the opposite or same side of the plane if of the plane which is given by this particular expression, if I have the expression ax1 plus by1 plus cz1 plus d, which is the point A satisfying inside this equation of plane, and ax2 plus by2 plus cz2, this cz2, okay, which will be also of the same sign. So if I have, so for example, this particular equation of plane, so I'm calling this particular equation of plane by some expression q. So if I put q of that particular point A and multiply with point P, q of B, if I'm getting this as positive, then both A and B will lie on the same side of the plane. And if I'm having the multiplication of this, so if I'm putting the value of point A and point B on this equation of the plane, and we are equating the product of that, and if we are getting that particular product as negative, then we say that that particular point will lie on the opposite side of the plane. So if both of these expressions are negative or of opposite sign, that is, one is positive, one is negative, so therefore the combined product is going to be negative. Right. So the combined product is going to be negative. So if the product is negative, then we will say that the point A and point B will lie on the opposite side. That is about the nomenclature, or try to understand what is the location of a particular point with respect to a given plane. right? Now our next task to understand is that if we are having the given point, let us say if I need to find out what is the perpendicular distance from a given point to the given plane. So if I need to find this perpendicular distance, so if I need to find out a perpendicular distance from point P to this particular plane, then how do we need to find out that distance? So that I will write it as distance. That particular distance is given by this particular formula over here. So this point x dash, y dash, z dash, we just put that point into this equation of the plane and then divided by the square root of a square plus b square plus c square. That's how we approach the answer of the particular perpendicular distance. Okay. I hope this particular part is clear. All right. Please give me a thumbs up if this is clear or not. This one is clear, right? Okay, so one more announcement, okay, that we are also coming live at 8:30 p.m. Okay, so we are coming live at 8:30 p.m. Please make sure that you don't miss out on that part, and that is very, very important. So we are coming live at 8:30 p.m. where we will be discussing about the top important questions for your CBSE examinations, top 10 questions. Okay, so please don't forget to hit the notification or the bell icon beside the subscribe button so that you don't miss out that upcoming notice on that. Okay, so we will basically come live at 8:30 p.m. discussing the top 10 important questions for your CBSE examination. So with this I will basically help you out with all of your important questions, and your any confusion if you have, you can definitely contact me on that particular session. Okay, so I will be seeing you all live in that particular session, right? So let's start. Okay, so let us come back. So I hope you will be coming and live, watching this particular video live with me. Okay, so let's start next. Move to the next point is that we can also find the length of the perpendicular in the vector notation, and that is simply given as a dot n minus d divided by mod of n. That is something the definition from basically the definition of the perpendicular vector. Okay, so the length of the perpendicular is from a particular point having the position vector a to the plane, which is given by this definition, is basically given also in the vector notation as this way. Okay, this is nothing but you can just see, you can just replace from here also. So it is just a Cartesian representation and this is the vector representation. All right. So this part is clear. Okay, now with this, let us move to the next thing, that is basically to understand that if we have a point and if we just drop a perpendicular from a particular point onto the plane, what is the foot of perpendicular? So if I have a point A and if I draw a perpendicular from the point A to this plane, then the foot of perpendicular P is basically given by this notation. So if I need to drop a foot of perpendicular from a point x1, y1, z1 to this plane, then the foot of perpendicular is given by z dash, x dash, y dash and z dash, and that is basically given as x dash minus x1 divided by a is equals to y dash minus y1 divided by b is equals to z dash minus z1 divided by c is equal to minus of a times of x1 plus b times of y1 plus c times of z1 plus d divided by square of divided by the summation of all the square of the direction ratio of the normal vector to the plane. And for the case of image, you will see that this particular thing only varies with the multiplication of 2, because image is the more than the point. So this image is basically like this, right? This it is called as a dash. So we know that this perpendicular distance must be same. So it is like that twice the perpendicular distance from the point A to the plane. So when we multiply with twice, we basically get the coordinate of the plane image. So coordinate of the image is basically given in minus of 2 times, and the coordinate of foot of perpendicular is given as only by minus of that particular constant. I hope this particular concept is clear. So please make sure that you write this particular definition clearly, and you please make sure that you write this particular formulas in your concept. Okay. So if you are understanding with this particular part, then I hope you will have no questions. So with this, we can basically start with the initial questions. Okay. So this part is clear, right? So let me know in the comments. Is this clear or not? Shall we start with the questions? Is this clear or not? Shall we start with the questions? Shall we start with the questions? So let us start with the questions. Okay. So this is the first question on your screen. So as you can see, the first question. So you can see the first question on the screen. So I would request all of you to please try this particular problem. So I would request all of you to please try this problem. So if you just look at the problem is basically talking about you have to find out the distance of a particular point. So what you will write, you will start writing with a given. The point is given as, so the point is given as -1 comma -5 comma -10, and you have to find the distance of the point from the point of intersection of the line and the plane. So you have one line and the one plane, right? So equation of plane. This is a very interesting problem, and these types of problems are basically usually repeated. Okay, these types of problems are repeated many times. Okay, so as you can see from the repetition, these problems are very much repeated. Okay, so please don't, make sure that you practice these types of problems very important and cautiously. Okay, so the equation of the plane is given as r vector dot the normal vector is given as I cap minus j cap plus of k cap is basically equal to 5, right? So from here we can simply write the equation of the plane. So we just write the equation of plane. So equation of plane will be basically x minus y plus z. So I'm just converting this part into the portion of Cartesian equation. So that is basically equal to 5. That is my equation of plane. That is my general equation of plane, right? We have the point, and what is my equation of line? Now please, again and again I'm repeating, please pardon yourself from using these abbreviations, okay? Because abbreviations will actually help, will deduct marks, okay, when you're actually writing the paper for your actual exam. Okay, so make sure that you pardon yourself from writing the abbreviations. So make sure that you write this full part equation, okay, not eq to the power n. That is a short form notation, right? So equation of the plane is basically given as r vector is given as 2I cap minus j cap plus 2k cap plus lambda times of 3I cap plus 4j cap plus 2k cap, right? So if you recall from the initial definition of the equation of line, so if you recall from the initial definition of equation of line, it is basically given as a vector plus lambda times of b vector. So b vector is basically the direction ratio of that, or the direction vector of the particular line, and a vector is basically the position vector of any particular point that is lying on the line, right? So from here we can simply write this particular equation of the straight line in the Cartesian coordinate as x minus 2 by 3 is equals to y plus 1 by 4 is equal to z minus 2 by 2, right? So from here I can definitely assume any point on the straight line by equating this particular part to lambda, right? So any point in the straight line, let us call that particular point as some point b, right? Let us call that particular point as b, which is lying on the straight line. So that particular point b will be given as 3 lambda plus of 2 comma 4 lambda minus 1 comma 2 lambda plus 2, right? So now this particular point lies on the plane. This particular point will lie on the plane, so therefore it will satisfy this particular equation. So from here I will basically simply satisfy this particular equation into the equation of the given plane. So from here I will get 3 lambda plus 2 minus 4 lambda minus of 1 plus 2 lambda plus of 2 is equals to 5, right? So from here I will solve and get to the value of lambda. So quickly solve this and tell me what is the value of lambda you are getting. So if you just solve this, you will find out that you will get this part as lambda, because 3 lambda minus 4 lambda is minus lambda plus 2 lambda is lambda, right? And this part is going to be 3 plus 2, that is equal to 5. So you will see that lambda will be equal to 0. So if you just solve this, you will get lambda equals to 0. Okay, so you will find out that simply the value of lambda is equal to 0. So if lambda equal to 0, so therefore that particular point where the line and the plane is intersecting, where the line and the plane is intersecting, that particular point B can be simply given as 2 comma minus 1 comma 2, right? Now I need to find out what is the distance from the point A, which is given as minus 1 comma minus 5 comma minus 10, right? Now we'll simply use the distance formula between 2 points to find out that particular distance AB. So the distance AB will be given as square root of 3 square, that is the difference of the x coordinate square plus difference of the y coordinate square plus difference of the z coordinate square. So 3 square plus minus 1 minus of 5 minus of minus 5, that is going to be 4, right? 4 square plus 2 minus of minus 10, that is going to be 12, right? Now this will give me the answer basically equal to 13 units. Okay, this will give me the answer as 13 units, because 3 square plus 4 square is basically equal to 5 square, 25, right? So 5 square plus 12 square is basically equal to 13 square, that is square root of that is basically going to give me 13 units. Please make sure that you don't forget to miss out writing this entire answer as 13 units. Okay, so because you are given to find out a distance, so distance must have some unit to it. Okay, so don't forget to write the answer like this way, right? So this is how you are going to actually solve the question in the exam. Are you getting this part? So I hope this part is clear. Please let me know if this part is clear or not. This part is clear or not? So if you understand this part, shall we proceed with the next problem? Can we proceed with the next problem? So what you can see, observe is that this is a very important and crucial problem. Please make sure that you practice these types of problems carefully. Okay, very simple problem. Just you need to assume any point on a given straight line and satisfy that particular point to the equation of plane in order to get to the unknown value of lambda. Okay, so this is clear, right? This is clear to all of you. Is this clear to all of you? Okay, so with this, let's move to the next problem. So next problem is again, so let us try to start with the solving this first problem over here. Okay, so let me label it first of all. This is the first, this is the second, and this is third, right? Now why did I take these so many problems together? Because you can see that there are a similar type of problem that you can see on these three types, right? These problems involves the straight lines concept in 3D. Okay, so please try to solve this first problem. Okay, please try to solve this first problem. Please try to solve it first problem quickly. I'm giving you some time, 2 minute time. Okay, please try to solve this problem and tell me the answer you are getting. You have 2 minutes time. Try to solve it. Please try to solve it. You have 2 minutes time. Start solving it. Try to read the problem carefully and try to start understanding the problem. Okay. So is it done? Is this done? So hello everyone. Is it done? What's the answer you're getting? Kindly let me know what's the answer you're getting. So if we look at the problem over here, let's try to understand what is the question talking about, right? So we need to find the vector equation of a line which is passing through this point 2 comma 1 comma 3, and it is perpendicular to the two given lines, right? So we have to basically find out equation of a line which is perpendicular to two lines, right? So let us say I have two lines whose direction ratio of the vector along with the line is point directed is given as b1 vector, and this particular vector is given as b2 vector, right? And I have to find out a line which is perpendicular to these two lines. It is perpendicular to two lines and it is passing through a particular point, and that particular point A is given as 2 comma 1 comma 3, right? So it is perpendicular to both the lines and it is passing through 2 comma 1 comma 3. So in order to see and look at this problem, so if we need to find out what is the equation of the particular line over here, so if you recall from the definition that any general equation of the line in the vector, since we need to find out vector equation, right? So that can be given as any vector position vector of the line of the point that is lying on the line plus lambda times of the direction ratio along with the line is directed, right? So in order to find the direction ratio, what do we need to do? Now, since this particular line is perpendicular to this line 1, so let us call this line 1 L1 and line 2 as L2. It is perpendicular to the L1 and L2. What I will do over here, I will first of all try to find out a vector which is perpendicular to B1 vector and B2 vector. How do we do that? So our B vector, the required direction ratio of the or the direction vector for the perpendicular line is given as B1 vector cross B2 vector, right? So if we just need to perform the cross product, right? So if we just perform the cross product, so we just get I cap, j cap and k cap. That is basically, so if we look at the equation of the given, so the denominator over here basically talks about the direction ratios, right, of the given line. So from there we put it over here, so it is 1 2 and 3, and this one is -3 2 and 5. These are the direction ratio of the vector of the given two lines, right? So from these two lines I will find out the cross product, which will basically come out as I cap times of 10 minus 6, that is going to be 4, minus j times of, I hope you know how to find a determinant, right? It is a summation of the cofactor with the multiplication with the given any row or any column of the given determinant. So I cap times 4 and j cap times minus j cap times 5 minus of minus 9, that is going to be equal to minus of plus of 14, right? Plus k cap times of, that is going to be 2 minus of minus 6, that is going to be equal to 8, right? So from here I will get the general direction ratio, the vector which is directed along the perpendicular to this two line, right? Which is basically given as this particular vector, B vector, right? So once I have generated the required vector which is perpendicular to two given lines, then I can simply find out the required equation of vector equation of line as simply as, so our point on the line is basically given as 2 I cap plus j cap plus 3 cap plus lambda times of 4 I cap minus 14 j cap plus of 8 k cap. Is this clear or not? Please let me know if this is clear or not. This is a solution for the first part, okay? So when you are writing the solution in the actual paper, please make sure that you follow the entire step properly, and you please make sure that if it is possible, if time permits, make sure that you don't miss out on the diagram. I would say that time permits or not, you have to do the diagram, because if you are doing the diagram, that will show the examiner that you are very clear with the entire concept, and you can definitely easily solve what is the given problem, okay? I hope this part is clear. Let us now proceed with the second problem. So if you just look at the second problem, okay, so if you look at the second problem, it is said that we have to find the vector and the Cartesian equation of a line which passes through this particular point and is parallel. Now instead of giving you it is perpendicular to a particular line, but it is saying that it is parallel to this given line, right? So whenever a line is parallel to the given line, the same direction ratio of that particular lines will be repeated, or will be some scalar times or multiple times of that particular direction ratio. So if you just look at the given line, so what we can see, so I am doing the second page. So equation of the line which is parallel to given line b basically r vector, okay? Now the given line is given as Now if you just look at the given line equation, it is basically given as x minus 5 by 1 upon 5. I just simplifying it, right, into the general notation of the Cartesian coordinate equation of the equation of line, right, x minus 5 by 1 upon 5, and it's equals to y minus 2 by taking 7 as common, or minus 7 as common. So I can write it as minus of 1 upon 1 by 7. Just look it over here. So I took it minus 7 common, so y minus 2, and then so minus 7 will go in the denominator and it will be basically become minus of 1 upon 7, and which is equal to, and if you look at z, it is basically z upon 1 upon 35, right? So what you see that the direction ratios of this particular line, let us call this as b1. This is basically given as 1 by half times of lambda plus, sorry, minus 1 by 7 times of j cap plus 1 upon 35 times of k cap, right? So from here, I can definitely write the equation of the line R as equals to some position vector which is lying on the particular line plus some lambda times of this B1, right? So from here, I can definitely write both the vector equation as well as the Cartesian equation, right? So this is the required line. Okay, so this is how you are basically going to approach the problem. Okay, I hope this solution is clear enough to all of you. Similarly, if we look at this next problem, the second part of the problem, okay, sorry, this one is a fourth problem. Okay, this part is a fourth problem. So in this problem, it is said that you have to find the value of k, which is unknown, such that this particular line and this particular line are perpendicular to each other. So if a line are perpendicular to each other, what you have to do, you have to just take the dot product of the given direction ratio of the vector, direction vector, right? So if you just do the dot product of the given direction vector, you are going to get the answer as 0. So let us say the first line direction vector is basically given as b1 vector, and the second line is given as b2 vector. So I will just do the dot product and equal it to 0 in order to get to the perpendicular condition, right? So if you just look at this problem, so first line has a direction ratios 1, minus 1 and 1 upon k, right? And the second line, it has a direction ratios 1 comma 1 comma 1 upon 2 comma minus of 1, right? So we just need to perform the dot product. So if you just do the dot product over here, it is very quick and simple, right? These are all the 2 marker problems. Okay, so if you just do the dot product, we will get it 1 minus of 1 by 2 plus minus of 1 upon k, which is equal to 0. So from here you will get 1 upon k is equal to 1 upon 2. So therefore you will get the value of k as equals to 2. Okay, so I hope you have understood how to solve this problem, right? This is a very simple problem. You just need to perform the dot product and equal it to 0. That's the condition for two vectors to be perpendicular to each other, right? Similarly, there is one more problem. If you can see, the third problem is basically similar, repetition, exactly repetition of the problem. That is basically the second problem, right? So you can see that is asked in 2023, and similarly the third problem is also was earlier asked in 2017, right? So you can see there are problems which are getting repeated, exactly repeated. So make sure that you are following this all previous year lectures. Okay. So if for your all your surprises and your benefits only, I am basically taking up this previous year lectures. So if you are someone who is new and haven't watched the initial previous year lectures, I would recommend all of you to please subscribe to the channel and go to the description of the channel. You'll go to the channel under the live tab. You will find out all the sessions that I have taken so far. So we have already covered the entire class 12 syllabus, right? So if you haven't started watching that particular part, please make sure that you do the same. Okay, so let me know in the live chat if you are done with this part. So we have solved total of 5 problems, right? So let me know in the comment section if you are understand. Did you understand this part? Did you understand this part? I hope this is clear, right? This one is clear to all of you. Okay, so let us now proceed with the next problems. The next problem is basically that we have to show that two given lines are coplanar. What do you basically mean by coplanarity, right? So if I recall, let us try to understand what is coplanarity or coplanarity condition, right? So if you recall from your initial study of vectors, coplanarity condition is basically related with the vectors lying on the same plane. So if I are able to find out three vectors, if they are basically lying on a particular plane, let us say I have information about the three vectors, A vector, B vector and C vector, right? So let us call this A vector, this B vector, and this C vector, right? So if these three vectors are lying on a plane, then we need to simply equate their scalar trivial product equal to 0. So if A vector, B vector, and C vector are lying on a plane, the scalar trivial product, which is given by box of A vector, B vector, and C vector, I will equate it to 0. This is called as a scalar trivial product. So the scalar trivial product basically gives me the volume of the parallel pipe. So in case the vectors are basically are coplanar, then the volume of the parallel pipe is basically equal to 0. So this is the scalar product. So therefore we will get the scalar product equal to 0, right? Also, if you just recall, so therefore what I was basically talking about is that volume of parallel pipe, right? Volume of the parallel pipe with the adjacent adjacent side vectors as A vector, B vector, and C vector. That means if you draw a parallel pipoid, right? It is a 3D figure whose all the sides are parallelogram, right? So this is basically a parallel pipoid whose initial adjacent or terminal vectors are basically given as A vector, B vector, and C vector, right? So if you have this, in the volume of the parallel pipe, it is given by box product of A vector, B vector, and C vector. Okay, that's how the simple the result is. Okay, so with this particular result, if I have to discuss about two lines being coplanar, the condition is basically like that. So if we look at this problem, we have two lines which are coplanar, right? So if you just look at the first line, the equation of the first line is given as x minus 5 by 4 is equals to, now it is always recommended to please write the unknown on the left side, that is x minus 5 instead of 5 minus x. Okay, so x minus 5 by 4 is equals to y minus 7 by 4 is equal to z plus 3 by minus of 5. So from here I can write the any point in this particular point line as 5 comma 7 comma minus 3. Similarly, any point in this second line can be given as 8 comma 4 comma 5. So I have 2 points. So from this 2 point I can generate one vector. Also I have two vectors which is directed along the lines, right? So with this, what I will do, I will just, so if I have called this particular position vector of the point lying on the first line as R1 and the position vector of the point lying on the second line as R2. So and also I have the directions of this first line is B1 vector and the second vector as B2 vector. The condition for this coplanarity is basically will just make the scalar trivial product of R2 vector minus R1 vector, B1 vector, and B2 vector and equal it to 0. So I will just take this STP or scalar trivial product. Okay, I'll just take the scalar trivial product and equal to 0. Now how do we solve for this scalar trivial product? So for that I will do the determinant. So x R2 minus R1. So I will write the x coordinates over here. That is basically going to be any point on this. So let us say that R2 is basically x2 comma y2 comma z2, which we already found out. And similarly this one is x1 comma z1 comma y1 comma z1, right? So I can write it as x2 comma x2 minus x1, y2 minus y1, and z2 minus z1, right? And this one will be basically b1x, b1y, and b1z. Similarly, this is going to be b2x, b2y, and b2z, right? Now what is this b1, b2? This is basically just the components of b1 vector along x, y, and z, and these are the component of b2 vector along x, y, and z, right? And we just need to simply equate this determinant equal to 0. So if you are doing these steps, you are basically going to get the equal answer of the condition that whenever two lines are coplanar, then you have to just equate this particular condition. Okay. So if you are able to show that this particular determinant is equal to 0, then only you are going to prove that these two given lines are basically coplanar. Is this clear? Please let me know. So I am not solving it entirely. Please solve it on your own. So please solve it on your own and tell me what is the answer you are getting. Please let me know in the comment section. Please let me know in the comment section if you are clear with this or not. So I'm going through your live chats. Is this clear? So this is how you are going to prove the problem. Okay. So I have given you the underlying concept behind how you are going to solve this problem. Okay. Is this clear? Alright. So I hope this part of the solution is clear. So this is how you're going to prove this problem. Okay. Now these types of problems are also very crucial and important for your CBSE examination. This was a problem of like 3 marks. It was a problem of 3 to 4 marks problem. Okay. Maybe some year it was asked as 3 marker problem, some year it was asked as 4 marker problem. But this is a very important problem. So make sure that you don't miss out on this problem. Okay. With this, let's move to the next problem. So next problem we have to basically discuss about to find the image of a particular point on the plane, right? So if you just simply apply the concept, first of all, let us try to write the given point. So our given point, let us call that particular point as, so our position vector of the given point is I cap plus 3j cap plus 4k cap, that is 1 comma 3 comma 4, right? And the given equation of plane, so I will write the equation of plane in the Cartesian coordinate equation. Okay, that is basically I can write this as 2x minus y plus z plus of 3 is equal to 0. So in order to find the image, so let us say that the image of point A is basically given as a dash. So I will find the, so let us say the coordinate is x comma y comma z. So the image of this is basically image. Okay, so image of point is basically given as x minus 1 upon 2 is equals to y minus 3 upon minus of 1 is equals to z minus 4 divided by plus of 1 is equals to minus of 2 times of, just put this particular point in this equation of this plane. So if you just put this in the equation of plane, what we are getting, don't equate it to 0. We just need to put the value into the equation of plane and let us see what is the expression we are getting. So we just put 1 comma 3 comma 4 into the equation of plane, we are going to get 2 minus 3 plus of 4 plus 3, right? So this minus 3 plus 3 get cancelled and you are going to get 6 divided by square of the direction ratios, sum of the square of the direction ratios of the normal vector. So you know that this 2 minus 1 and 1 is basically the direction ratio. So this is going to be 2 square plus 1 square plus minus of 1 square, right? So if you just solve it for these 3 individual ratios, we are going to get the image. So if you just look over here, so x minus 1 upon 2 is equals to minus of 6 and divided by, so 2 divided by 6, that is going to be minus of 1. So from here I will get x equals to minus of 1. So the x coordinate of the image is equal to minus of 1. Similarly, y minus 3 divided by minus 1 is equal to minus 1. So from here I get y is equal to 4. So the image y coordinate is going to be 4. Similarly, if you find out z, so z minus 4 by 1 is equal to minus of 1. So z is basically equal to 3. So therefore you obtain the coordinate of the image as minus 1 comma 4 comma 3. Okay, so for the given point 1 comma 3 comma 4, this image is going to be minus 1 comma 4 comma 3. This is clear, I hope, right? This part is clear. This is very simple, right? So if you just analyze the problem, you are going to basically get it. Okay, so what is the concept we are using? Since this is an image, so consider this mirrored as the plane, so which is going to be perpendicular, right? Also you can solve this problem by considering this foot of perpendicular. So you can know how to find a foot of perpendicular. So if you know the foot of perpendicular, so for this line a dash, this foot of perpendicular is going to be the midpoint. So we can also use the midpoint formula to get to the point of a dash. But why to do this? You directly have the formula, you can apply it, right? I hope this part is clear, right? So these were all the important questions that you are going to approach or come across in the topic of planes, right? Now I have kept some problems for your homework. Okay, now please go through this problem and please let me know what is the answer you're getting, and please comment me in the comment section. This problem is very simple. You just need to apply the concept of a planes, right? So for plane, what is the most important thing to find here? One point on the plane, one point which is lying on the plane, and one normal vector which is perpendicular to the plane, right? So if you have these two informations, you can definitely write equation of any general plane. right? So please try to solve this problem in as a homework. I have already told you all the underlying concept behind it, right? So these are the homework problems. Please take a screenshot if you can. Please take a screenshot. Now there is something that is very crucial to understand in this problem is that, so let me tell you that underlying concept behind it. Now, when we discuss a plane, when we discuss a plane and a line, when we discuss a plane and a line, so the angle which the plane makes with the line is basically, this is the angle, which is quite called as theta, right? But for a plane, the vector which we know is the direction, perpendicular vector, right? And for the line, we know the vector, this is a b vector, right? So if I just perform the dot product, and from there if I get to the angle between n vector and b vector, I'll get this particular angle, right? So this is perpendicular to the plane, so therefore I can write this particular angle as 90 degree minus of theta. So therefore, when I perform the dot product between n vector and b vector, that is n vector dot b vector, I'll get this as mod of n into mod of b into cos of, instead of theta, I will get it as pi by 2 minus of theta, right? Because this part of the angle is the angle between the vectors b and n. That is going to be pi by 2 minus theta. So that will basically become equals to sine theta. So for the case of plane and a line, so angle between line and plane, so for the case of line and a plane, I will get sine theta as equals to n vector dot b vector divided by mod of n vector divided by mod of b vector. So that is what we are going to use. So instead of sine theta, you will get it as sine. So instead of cos theta, you will get it as sine theta. Okay, that's the only difference that you are going to use when you are going to find out the angle between plane and a line. So I hope this particular concept is clear. So with this concept, you can definitely solve this problem, and let me know in the answer in the comment section. Okay. So this was all about the differences of problem that you are going to face in the chapter of 3D geometry, consisting of straight lines, planes, as well as concepts of direction ratio, direction cosines. So with this, I declared the end of the entire syllabus of CBSE Class 12 Board examination. So don't forget to stay tuned in this particular sessions. Okay, so if you are someone who is new and watching this content for the first time, make sure that you like and subscribe to this particular video, and please subscribe to the particular channel and hit the bell icon so that you don't miss out any upcoming notification of the content. We are going live every day, and we are going to discuss every concepts of CBSE board examination so that you can crack your examinations. Okay, so also we are coming live again today itself at 8:30 p.m. So don't forget to stay tuned for the particular video. We are going to discuss about the top 10 important the top 10 important questions. Okay, so please make sure that you put an alarm at 8:30 p.m. So we are going to discuss about the top 10 important questions. Okay, so 8:30 p.m. we are coming live again. Okay, so make sure that you don't forget to hit the subscribe button. Okay, so click on the subscribe button, and we are coming live on the YouTube at 8:30 p.m. Please share this message to all of your friends so that we are going to hit all the important questions that are basically crucial for your CBSE board examinations. And with this, we will crack the entire paper, and we are definitely going to score 80 upon 80 in the theory paper. With this, I wish you all the best. Thank you.